Okay, so we have recently discussed different properties for logarithms. You can see I have those summarized here in this box here. And these properties show us how to add logarithms, subtract logarithms, make the lead coefficient a 1 by pulling it up in the exponent of the argument. These two properties here show us how we can either write a number so it looks like a logarithm or simplify when there's a log in the exponent. And this last one, the one-to-one property, is reserved exclusively for equations. If there's one log and only one log on each side, having the same base and one's in front, we are allowed to cross the log and base off, leaving behind just the arguments, and we would solve that remaining equation for x. One thing we want to keep in mind when we're solving these equations is when we get our answer for x, we always need to make sure that we are plugging that answer all the way back into the original for any x's, and we want to confirm that in plugging that back in, it wouldn't cause any of the arguments to either be 0 or negative. Logarithms arguments are not allowed to be 0 or negative. Okay, so we're going to go ahead and essentially just get a little bit more practice in here together. We're not going to do examples 1, 2, and 3. Today our main focus is going to be on working with the one-to-one property. There'll be other properties that will make appearances in this, but all of these problems are going to, oh, I'm sorry, that's not true. One-to-one property we're going to do here on the back. These two examples in number 4 are asking us to take what we see here and write it as a single logarithm, okay? Now, what you want to pay attention to is you want to see how many terms that you're dealing with here, okay? So, for example, this, I'm going to underline, is one term. This right here is a second term, and actually this -2 that you see on the end is a completely separate term. Had that -2 been part of the argument, then it would have had to have been in parentheses here. So I have 3 terms. This problem's wanting me to combine all 3 of these together into a single logarithm. So we always say we work our way from left to right. So let's focus right now on just trying to combine these 2 logarithms that we see here on the left. Now remember, the requirements are that the bases have to be the same. We can see that those are, but also the lead coefficients here for each of these logs have to be a 1. And we can see that here in this first one, it is not a 1, but that's what the power property says up above, that we can pull that 2 up into the exponent on the argument, writing it as log base 3 of x squared. Okay, once again, keep in mind we have 1, 2, 3 terms here. Okay, these are not equations, therefore you should not be crossing off logs. Okay, that is exclusively for the one-to-one property. Okay, now I should be able to combine these logarithms together. I notice that I'm adding these 2 logarithms together, which means what I should be doing with the arguments of those logarithms is I should be multiplying them. Okay, so that's going to make that, if I combine those 2 together, log base 3 of 45x squared. Okay, now we need to make sure that this is all combined together as one single term. Now you'll notice we have a logarithm here, but this number, -2, it doesn't look like a logarithm. Okay, now I'm going to scroll back up to the top. I'm going to highlight the property that we're going to want to use that's going to allow us to take a number and write that number so that it looks like a logarithm. If you're trying to disguise a number as a logarithm, you want to take that number, put it in the exponent on the argument, and make sure your base of your log and the base of the argument are the exact same 2 numbers. Now that's what we're wanting to do here on this problem. We need to change the number 2 so that it looks like a logarithm. And let's be smart about what we're choosing here. If the intention is to combine the logarithm that we're trying to create with this logarithm over here, then I should be making sure that it has the same base as this logarithm over here. So I'm going to choose 3 as the base, which means I also have to put a 3 as the base of the argument, and the number 2 goes all the way up in the exponent of that argument. So in reality, if you were given this problem, because these are the same, technically all of this reduces to the number minus 2. Okay, so now I can combine these together. When we're combining logarithms together, let's take a look here. We are subtracting these. So that means what we should be doing with the arguments is we should be taking this first argument and we should be dividing it by the second argument. Now I want you to just think of this second argument technically as being the number 9. That's what the argument would be. So this is going to be log base 3 of 45x squared divided by 9. Okay, of course we know that 45 divided by 9 would reduce to a 5, and then we have the x squared there. Okay, we're not solving for x. These are not equations. We don't need to plug things back in and make sure our arguments are positive. Let's go ahead and try a second one. We have 1, 2, 3 terms. The first term is not a logarithm. I need to turn that number 2 into a logarithm. I'm going to note that the bases of the other logarithms look like those are 2's. So that means when I'm turning this 2 into a log, and this is going to look funny, you're going to pick a 2 here, a 2 here, and then the original 2 that was in the problem is what you're putting in the exponent there. Okay, the other thing that we're going to want to do is we're going to want to pull this 3 up in the exponent on the 6, so it becomes log base 2 of 6 cubed. Okay, now we have this third logarithm, but I'm not going to do anything with it right now other than just kind of write it down. Okay, my focus is going to be combining these first 2 logarithms together. What you may want to do before you combine those together is you might want to take the argument and you might want to like square the 2 so that this is log base 2 of 4. You might want to cube the 6, so that's log base 2 of 216. Okay. Okay, just kind of cleans things up, makes it look a little bit nicer. Now we're going to take those first 2. I'm going to look at what are we doing with those first 2 logarithms. We're adding them. Okay, so if we're adding them, that's when I'm going to multiply the arguments together. So I'm going to be multiplying the 4 and the 216. That's going to make the new argument 864. And now I can combine the next 2 logarithms. I'm going to look at what we're doing with these. We're subtracting these. So when we subtract logarithms, we take the first argument, we divide it by the second argument. You might want to check on your calculator if 864 divided by 72 can be reduced. I believe it goes in there exactly 12 times. So that's going to reduce to 12. Notice though, there's still an x in the denominator, so it's 12 over x. Okay, that's writing things as a single logarithm. On the back, we're going to focus on the one-to-one property. You can see these first few problems I've done for you. Just a quick refresher. Never move something across to the other side of the equation. It makes things a little more confusing. It's best to leave things exactly where they start. If there's multiple logs on one side of the equation, fine. Combine them together, making sure they have the same base, making sure they have a 1 in front. Now notice on this problem that I did for you, we would be taking this argument and then this argument. If we're multiplying them, that x gets distributed to both the x and the minus 9. That's why you're seeing x squared minus 9 there. Okay, notice there was no logarithm on this side, so I had to turn the number 2 into a logarithm. Look where I put it. I put it in the exponent, and I chose as these 2 numbers 6's because I wanted it to have the same base as the logarithm on the other side. Okay, I then crossed off just the log and the base. That left 6 squared behind, making that a 36. Now this is a quadratic, everything to one side. I ran the quad program. You could also graph the parabola and find the x-intercepts. Okay, so let's go ahead and move down. You can look at example B if you want another one just to kind of look through. Let's go ahead and try example C together here. Okay, what we're going to focus on with C is we're going to look at our equation and say, okay, we have 2 logarithms on the left side. I need to combine those 2 logarithms together. Currently, they both have the same base, and they both have a 1 in front of it. Okay, so I'm going to look at what am I doing with these 2 logarithms. Well, I'm adding them, so that means I'm going to have to multiply their arguments together. So I'm going to distribute that x. That's going to make the new argument x squared plus 5x. Okay, now I've successfully combined these two logs so that I'm on my way here with the one-to-one property. I've got one logarithm on the left. What I need to do now, though, is I don't have any logarithms on the right. I need to turn this number 2 into a logarithm. So I'm going to look over here. I see my base is 6. So I want to make the base of my log over here a 6. I also need to make the base of the argument a 6. And then the original number that you're turning into a logarithm, that goes in the exponent. Okay, so technically what we have here on the right side, and I'm just going to rewrite the left side here, we have log base 6, and technically the argument is a 36. Okay, now we are set to do the one-to-one property. So the one-to-one property says you're allowed to cross off the log and the base, provided you only have one log and only one log on each side of the equation. Okay, I'm left with the arguments that are equal to each other. Again, this happens to be a quadratic. I'm going to move everything to one side, run the quad program. These are the two answers that I initially get when I run the quad program. You should refrain from circling them, though, until you take each of these one at a time and go back to the original problem, substitute a 4 in, make sure that that's not going to make either of these arguments negative or 0. Substitute a -9 in. Oh, if we stick -9 right, even just right here, that's going to make that argument negative. So I am going to throw out the -9, and I'm only going to circle +4 as my answer. Okay? All right, example D, one-to-one property. I look at the left side, I see 2 logarithms. I look at the right side, I see 1 logarithm. So I'm good to go here on the right side. But I need to combine these 2 logarithms together on the left side. I'm seeing it's good that they have the same base. However, I need to pull that coefficient up into the exponent so that both of these logs that I'm trying to combine together will have a 1 in front of them. All right, so let's go ahead and combine. Now, make sure that you're paying attention here. We are subtracting these 2 logarithms, so that means I'm going to be dividing their arguments. X to the 4th over 5, and that's going to equal the log that I have over here on the right side. Okay, I think we're good to do the one-to-one property now. I've got 1 logarithm on each side of the equation. They have the same base. They have 1s in front of them. I'm crossing off the log and the base. That leaves behind the fraction x to the 4th divided by 5 equals 125. Okay, so I'm going to solve this for x. I'm going to move the 5 to the other side. 125 times 5 is 625, and then we need to take the 4th root of both sides. I know we've talked about how to do the cubic root before. I want to show you how to do the 4th root on your calculator. Okay, what you're going to do, and this is going to seem a little weird, but on your calculator, you're going to actually press the number 4 button first. Okay, so press number 4 and then hit the math button, and you're going to pick, I think it's option 5. What it's going to look like is it's going to look like a square root, but there's going to be an X where the root is. Okay, now when you select that, on the newer calculators, it'll automatically push that 4 right into the root. So it looks like it's the 4th root, and then obviously you would type 625. On older calculators, it's still going to look like this on your screen, but just know that the calculator understands that you're saying that 4 goes right in there where the X is. Go ahead and just type 625. This is going to come out to an answer of X equals 4. Okay, X equals 5, not 4. Okay, X equals 5. Okay, now we need to check this. If you were to plug 5 back in here, for the X, that's not going to make that a 0 or a negative, so we can keep that as our answer. Okay, we're going to do one last problem here together, and then there'll be some problems out of the book that you can go ahead and try that'll have you practice kind of this one-to-one property. So looking at this last one, I'm seeing, okay, we've got 2 logs on the left, we've got 1 log on the right. The good news is all the logs have the same base. You're not allowed crossing off any logs, though, until you have just one log on each side. So let's take a closer look. What are we doing with these logarithms? Oh, we're adding them. That means what we really should be doing with these arguments is we should be multiplying them. So I'm going to multiply 2x and 7, and that's going to make the argument 14x. Then when I do the one-to-one property, I'm going to cross off the log and the base 3. That's going to leave behind 14x equals 28. Now here's an example. This is not a quadratic. There's no x squared here. So I'm not going to move everything to one side. I'm not running the quad program. I'm just solving this like a regular algebra equation, dividing both sides by 14. I initially get that x equals 2. I'm just going to do a quick check. If I were to plug 2 into the original, that's not going to make that argument a 0 or a negative. So this is definitely an answer that I would be keeping. Okay, once again, you can see at the top of the notes page here are a few problems for you to go ahead and try from the